Technology behind a railgun is particularly interesting to me, so I chose an article regarding the topic. More specifically, the article I chose focuses on using nonlinear dynamic equations to calculate the free vibrations in a mechanical railgun when it's being fired. Now that's an earful, so I'm going to break that down and explain what all of it means. A railgun is a method of firing a projectile that doesn't use propellant or any type of explosive. It focuses on electricity and electromagnetic fields to launch a projectile at faster than Mach 6 speeds. If you don't know what Mach 6 says, that's 4,600 miles per hour. It's the fastest we can launch a projectile currently. This is an example of a railgun being fired. As you can see, it slices through steel plates like butter. Now, how does a railgun work? You have a current that travels down one rail of the gun. It will transfer onto an armature and down the other rail. This current is generating a Lorentz force, which you can understand by using the right-hand rule. It has the current traveling this way, a force traveling this way, and another force traveling up. While it's doing this, it's creating a counterclockwise moment about the rail. The two counterclockwise moments that are being generated about the rails are going to generate a magnetic flux density within the volume contained here. Now, when this magnetic flux density comes in contact with the current traveling through the armature, it's going to propel it forward at speeds higher than Mach 6. It doesn't always use the armature as the projectile. Sometimes the armature will have a projectile in front of it that it just launches, and sometimes it will be the projectile itself. The railgun, however, is in very early stages of development. Despite being developed in the early 80s, it's still not going to be seen as standard issue for a very long time. The US Navy is looking to replace long-range artillery with it, but it could be years before that, and even decades before it's seen on anything other than a naval carrier. The biggest problem that the US Navy has identified with the railgun is firing multiple shots in succession. A team from the Mechanical Engineering Institute in China wrote the article that I am summarizing that focused on using nonlinear dynamic equations to calculate the vibration frequencies within the railgun. Every time it's being shot, these rails are vibrating a ton, and previous methods for calculating those vibrations had errors of up to 17%. Those errors are huge, and if the Navy doesn't look at adapting these new methods, they may never be able to get the technology right. So what I'm proposing is that the Navy uses these new equations to calculate the vibrations, and maybe they'll be able to advance forward in firing multiple shots from their railgun.